Greetings and welcome to the Brain Gauge channel. This is a question and answer section, and we got a question from one of our viewers. Does the limbic system impact brain gauge scores? The short answer to that is yes, absolutely it does. Now, if that's all you're looking for, then have a great day. Otherwise, we'll go into a little more detail, and then we're just going to give an overview on this in this question and answer system. Later, there'll be longer talks on the limbic system and how it interacts, how it affects brain gauge scores. So let's just go on to the next slide, and let's just think about homeostasis. Homeostasis is sort of the yin and yang of physiological systems. And, one way to think about this is simply say, okay, let's say a bear starts chasing you. And if a bear starts chasing you, you immediately you sort of drop everything and run. And your body does the same thing. It's like focused on everything you can do to run better. Heart rate goes up, blood pressure goes up, and you're taking off. And now it's not just it's cranking up things, it's also turning off things. For example, it's turning off your digestive system, because who cares about digesting that meal if you're going to be someone else's meal? That's the way physiological systems work. The brain is no exception. And let's talk a little bit more about the brain in specific, and what happens when one system in the brain is hyperactive. And this happens a lot, and actually it's a cause of a lot of neurological problems. A lot of neurological disorders have this imbalance between excitation and inhibition. And again, I will go into this in a longer talk, but I just want to get the answer out there. But let's think of it this way. If you have what you have are different areas, and they're connected with inhibitory and excitatory inputs. But for the most part, when one area becomes super excited, it suppresses the other area. And so that's the way to think about this, is that you have inputs coming in, and if this area gets really excited, well, it starts turning these other areas off a lot more. That's what these red lines, that's what those connections are doing, is they're hooking up and either turning on inhibitory inputs, or they have inhibitory projections to the adjacent areas. Pain is a really good example, and it's something that we studied a whole lot of, because we were somatosensory people. And that's, by the way, the only place pain inputs come into the system are through somatosensation. But I'll try not to distract myself, and I'll answer the question. Basically, the pain system is sort of like, it's right next door to the area that handles mechanical inputs. And so when those, and this is on one scale, of course, but within the somatosensory world, if you input and activate the one area or the pain area, then you start suppressing this other area. And what happens in an acute situation is that those areas are a little different, and they will change some things. But if it's long term, if this area is very, very hyperactive long term, then a lot of things start changing in terms of how homeostasis is reorganized. And that's called maladaptation. Again, that's for a longer talk. But we adapt to those things normally. And so this is, what happens when we do get under, when the limbic system gets overactivated. Well, you can think of the limbic system as just being another area. And it's an area that's right adjacent to the cortex, and it surrounds the thalamus, which inputs to the cortex. And so there's a lot of connections in between the limbic system and the other systems, and between the cortex. And so depending on what they do, it will suppress those scores. And is it an acute response, or is it a chronic response? That's another question that that you can see reflected in the brain gauge scores. So, for example, temporal order judgment, this score right here, that's impacted greatly by both acute and chronic stress conditions. And also the ability to focus. That's another one that's affected quite a bit by both acute and chronic conditions of stress and anxiety. And then now let's talk about pain. Pain has, because it's also related, pain has another effect on accuracy, an immediate effect on accuracy in acute situations. However, it also has a slight effect on plasticity in the acute condition, but in the chronic condition has a huge effect. And you can actually tell the difference between acute and chronic conditions in different subject groups based on those scores. And again, I'm making this answer way too long. So anyway, that's the thing to think about is what are the interactions and where are they going? And you can think of it in terms of, okay, what's shutting down when the limbic system is hyperactive? It's shutting down stuff in the cortex, because when you're really emotional, you generally don't function that well. Or if in the, like, just like in the getting chased by the bear, there's stuff shutting down in your brain as well as in your gut. So that's the way you think about stuff. And we'll go into more details about that. And if you ask more questions, I'll make more answers. But one thing is that we're running into a lot of people doing a lot of different types of things that will lead to recovery. And the scores you just saw there were the initial scores of a patient who actually did recover to these scores. And even and what you do when you do recover, you're reestablishing the proper balance between those areas. And the connectivity plays a huge role in recovery as well as it does in the maladaptive response. Anyway, that was a quick question, quick answer. If you got more questions, send them to me, and either to mark@corticalmetrics.com or info@corticalmetrics.com. And thank you for watching.